Okay, so here we're going to take a look at a couple more examples here where it's not always obvious what the substitution should be, or excuse me, what the UDV should be, or the substitution to be so that I can use parts, right? So here, for example, let's take a look at this example here, right? So let's take a look at cosine root x dx. Right? Now I can't really take the approach that I took with the natural log, right? Just because if I make this one, I still have this cosine root x that is it's giving me a hard time. It's going to give me a hard time. So what I'm going to do first, right here, I'm going to make a substitution here. I'm going to let u be the root of x, and that means that du is going to be 1 over 2 root x dx, right? Or solving for dx, 2 root x du is dx, right? But again, I don't want x and u's together, but I know what I designated the root x to be. It's u. So we get 2u du equals to dx. All right. And now we can substitute here, right? I'll do the 2 up, move the constant out front, and then we're left with u cosine u du. All right, now this is something I can work with, right? Changing the integral, change a variable essentially, so it's in u, right? A substitution. Now it's a straightforward parts integral, right? Where my differentiation function is u, my integration function is cosine of u, right? So these are with respect to u. So we get derivative of u is 1, and derivative of 1 is 0. And then here we get sine of u, and then negative cosine. And then we get plus, minus, plus, and here draw our arrows here. All right, and now we have, and again, don't forget the 2, u sine u plus cosine u, right, and always plus c. All right, and let's not forget, again, the integral was asked in terms of x, so let's substitute back. 2 root x sine root x plus cosine root x, and as always, the plus c. All right, so here's a different approach that required us to make a u substitution first, right? And then from there we were able to use parts. Okay. All right, now here our last example here is, let's say we wanted to evaluate here a definite integral from 0 to 1 of x cubed square root of 4 plus x squared. Okay. Now in this case, it's not entirely clear what should be my d and my I. Do I need to make a substitution here? So this one is a bit challenging, right? So when I look at this, I'm like, okay, well, it's not quite a inverse trig there in the denominator, in the root, right? So I'm gonna take a different approach here, right? So here I'm gonna use parts, but I need to take, right, a different approach here. I see I have 3 factors of x there, and I'm gonna split them up, right? I'm going to take 2 of them, so x squared, to differentiate, and I'm gonna save 1 for my root function there. So I'm gonna write this root function in the denominator as 4 plus x squared to the negative 1/2. Okay, all right. And then I'm gonna take the derivative of this, and I'm just gonna do it once. Right, and the reason for that is the one on the right, it looks kind of complicated. So let me see what the resulting function is. All right, now this is actually a straightforward u sub, right? Now how do I know that? If I look at this inner function, 4 plus x squared, the derivative of that is 2x, which again, that's why I split that x off there, right? In order to have that x. Now there's no 2 there, but that's okay, right? Remember, if it's a constant, you just divide it through. So that's 1/2. All right, and then I can use the power rule here, right? 4 plus x squared, right? Add 1 to negative 1/2. So that gives me positive 1/2. And then don't forget to divide by the new power. In this case, 1/2 is the same as multiplying by the reciprocal, which is 2. Okay, and now I'm going to stop here and rewrite the integral that I have left, because it's a straightforward substitution integral from here. All right, now worry about plugging in at the end here. So what we have here is, all right, this is going to be x squared. So notice here 1/2 and 2, they reduce to 1. So I get x squared 4 plus x squared to the 1/2. Right, and then over here we have, so let's watch our constant. So 2 times 1/2 is 1, but there's another factor of 2 here. So minus 2, the integral of 2x 4 plus x squared to the 1/2. And this goes from 0 to 1 dx. Okay, and once again here we have another integral, but this is actually can be done with substitution, right? This is just a power rule integral, right? And how do I know that? Because the derivative of 4 plus x squared is 2x, and I see it right out here. So it's simply 4, let me rewrite this here. All right, so 4 plus x squared, 1/2, we added 1, we get 3/2, times the reciprocal, 2/3. And that'll be evaluated at 1 and 0. Okay, so again, simple power rule, right? You can use substitution, but by now, hopefully you're confident enough that you can do the u sub in your head here without having to write it down. But if not, that's okay too. Apply a u substitution here where your u is 4 plus x squared. All right, and then from here we plug in, right? Plug in 1. All right, so 1 squared is 1. When I plug in 1 here, we get 5 to the 1/2, or root 5. And then here, minus 2/3, 1. That's 5 to the 3/2. And then minus, when I plug in 0, right, the first term goes to 0. The second term doesn't, right? We get 2/3. Here. We should be careful here. Minus 2/3 when x is 0, we get 4 to the 3/2. And then simplifying further, we get root 5. 5 to the 3/2 is the same as 5 times root 5. And then over here we have 4 to the 3/2, that's just 8 times so negative positive, so times 2, we get 16 over 3. Right, and now reducing this, I just want to write this. There's too many root 5s here, so let me write it all with a common denominator of 3, and we'll wind up with this is negative 10, and then 3 root 3, negative 7 root 5, plus 16 over 3. Right, that last part, just some arithmetic there, combining like terms and whatnot into this one thing. All right, but again here, the problem here is this. Another way where we can use parts, right? Where it's not as straightforward as some of our first examples here, but we can see that, well, hopefully you can see here how powerful a tool this integration by parts is if we can use it correctly.